Is disturbing me. Good morning, guys. Uh, my name is Dr. Shaibu. Some can decide to call me Dr. Shaibu. Please, good morning, guys. Uh, my name is Dr. Shaibu. Some can decide to call me Dr. Shaibu. Please, good morning, guys. Uh, my name is Dr. Shaibu. Yes, apology for that little hookup. Yes, that's the course code, CHM 101. That's the current course code. But we have carryover students. Some of them will register it as FSC 102, while others will register it as 112, while others will register it as 112. And the new course title is General Chemistry 1. That's the CC Mass. So, and for the carryover students, they need to know that the course course content has changed completely. They need to know that the course content has changed completely, and so they need to familiarize themselves with the new course content. And they should make sure they attend our lectures. So 6 of us will be taking this course for this semester. 12 of us used to take the course, but 6 of us will be taking the course, while and we intend to use a week. Each of us intend to use a week for now. If we have enough time, we can add more weeks to it. But for now, in order to enable us put something across to you, because we don't know when the university will tell us to have the first semester exam for year one. And that's the reason why we just want to make sure we see what we can do for the next 6 weeks or 7 weeks and push all some of the information across to you. These are the course outline that I will be teaching you. Outlines, you are expected to have information about atoms, molecules, ions, and chemical reactions. These are all what you know from your O-level chemistry. But at least we want to assume that you don't know anything, so we just push that information across to you. After which, we are going to discuss the modern electronic theory of atoms, and thereafter, how to write electronic configuration. You will agree with me if I ask you to write electronic configuration. Some of you, if I ask you to write electronic configuration today, for instance, if I ask you to write electronic configuration of I'm waiting for the laptop to respond. So if I ask you to write electronic configuration of say sodium, you know the atomic number of sodium is 11. If I ask you to write electronic configuration, some of you will write it as 281, while others will write it as 1s2, 2s2, 2p6, 3s1. So the question is, why, which of these two is correct? And I can tell you that the two of them are correct. But with the work you want to learn, what I want to push across to you now, you realize that we want to take you from writing the structure from A to writing the structure using B. And so it's a long story. And that's what that second part we'll be looking at, modern electronic theory of atoms. After which, you're now going to look at the electronic configuration, how to write it, and we look at some of the rules guiding it. But I can tell you, will not, because of time, I will not be able to push everything across to you. So what I'm going to do is to just paraphrase some of the information, after which we'll push some notes to you. And one will expect you to go and do some work on your own. So, definition of atoms, you all know that is the basic unit of a chemical element. They are the basic building of all matters. All these are what you know. And atoms are made up of subatomic particles. These are some of the information that we got later. That atoms are made up of subatomic particles. So these are some of the information that we got later. Uh, so we are going to discuss all this. They are very tiny. That's the subatomic particles that you know already, proton, neutrons, and electron. So, and I don't think that is any problem to you. How to define element is also not a problem. And you know that element consists of only one type of atom. So it's not a problem. We're also going to look at molecules. At this level, you should be able to differentiate between elements and molecules. A molecule is formed when two or more atoms combine with each other. So you can see single atom is not a molecule. So if I say oxygen atom is not a molecule, but it becomes a molecule when two of them combine together. Then you say a molecule of oxygen. But this first one, you refer to it as just atom of oxygen. So it's not a molecule, it's an atom. So you can have ozone, all the rest like that. So you'll see these notes later. And you can have complex molecules. You can have simple molecules like H2O is simple, O2 is simple, and you can have complex molecules like glucose. So all these are what you should know. Know that the exam is going to be MCQ, OBJ, and so you should expect that we'll give as many questions as possible. Please register online if you are here, and for those on YouTube, you can also register your presence there. And so you can have compounds as well. All these are what you are expected to know. Definitions and some of the examples. So you have all that on this slide. And you can note this question. All molecules are not compounds, but all compounds are molecules. True or false? You should be able to answer that. I don't know how we are going to do it, but we plan to compress all our lectures for a week, just for 1 week. So we're going to see if it's going to be possible. So each of these are not compounds because they contain only one type of element. So all these are so you should be able to differentiate. This is a compound now because you have more than one type of element combined. You can see this, but this won't be. So this is not, and this is not. But these two are compounds. So all these are some of the things that you should know. Ions, you also want to differentiate. You should be able to differentiate ions from neutral molecules. We're going to discuss later, for instance, if you have sodium, is 11. Remember, we're going to discuss this later, that it's going to have 11 protons. It's going to have 11 neutrons. Oh, sorry, 12 neutrons, and it's going to have 11 electrons. And so it's neutral. But when you have sodium plus, this is an ion. We expect that the proton is still going to be 11, but electron will have reduced from 11 to 10. And so that differentiates an ion from a neutral atom. And one thing you also need to know is that your ion can be negative or positive. All these are some of the things that you're going to see in the note that I'm going to send to you later. So you can have that, and you can have group of ions, carbonate, sulfate, nitrate. All these are groups of ions. So all these are what you should know. And so you're going to see the note that I'm going to send to you. You have something you can play with later, classwork, and you'll see all that. Now, to the second part of the lecture that I'm supposed to push across to you. So the second part of the lecture that I'm supposed to push across to you, you have development of atomic theory and atomic structure. Like I said, we want to move from the information given to us by Dalton. But before even Dalton, there are many philosophers that gave information about matter. So these is going to be some of the things that we're going to look at. But it's going to be story. And I can tell you, because of time constraint, we don't have that time to discuss all the expected stories here. But you're going to see the stories in the notes, and you can add additional information online and from textbooks. Let me just push it across to you straight away that most of the things you're going to see me discussing, you're going to see them in textbooks, any general chemistry textbook. Any general chemistry textbooks, you're going to see them there. And some additional information you're going to see online. So make use of online and textbooks to add information to some of the things that I'm going to give you. And atomic theory developed from many models theories. Sorry, in FSC 112, there is a topic that we use to teach science and technology. And we always discuss some of the models, but we don't have, it's not in the new curriculum that they asked us to teach this semester. Consequently, it will not be there. So, but at least, yes, Olamide, what can I do for you? We don't have much time. Unmute yourself, Olamide.
Yes, sir. Good morning, sir. I wanted to ask, which textbook do you recommend for us?
I said any
Because
general chemistry textbook. Any general chemistry textbook, we have information. Please put down your hand. So, without wasting time, so in arriving at some of the information we have today, they did a lot of, they put forward a lot of hypotheses and experiments. Ideas and theories in science change as new information is gathered. You're going to see this later. Models and theories are based on each other and further developed. For instance, you know that remember, you're going to see, if we ask you today, what is Dalton atomic theory? Most of you can read out Dalton's atomic theory. And one of the Dalton's atomic theory is that atom is the smallest indivisible particle. But from the information we know today, is that theory still valid? You're going to see today that we now know that atom is no longer the smallest indivisible particle. So many of them put forward a lot of hypotheses. Some of them carry out experiments on these hypotheses, and they put some theories forward for each of us to further develop. And so we have some information that we're going to look at. So some of you also need to put down some information like this. You have to, it's not in the note. The story that I will be pushing across to you, I will not be able to push everything across to you. But some of the things that you're expected to know is the early, which I want you to put down, early ideas in atomic theory. You better write, that's the benefit of you coming to class. Then evolution of atomic theory. We're going to look at that. So if you look at the early ideas, the early ideas in atomic theory state the postulate of Dalton's atomic theory. It states the postulate of Dalton atomic theory and also used the postulate of Dalton atomic theory to explain the laws of definite and multiple proportions. You remember that? With Dalton's atomic theory, it was possible to explain the laws of definite proportion, multiple proportion, and even law of conservation of matter. Okay? So, and the first story you're going to see is that of the early theories by philosophers such as Democritus and many others. Leucippus and what did they propose? Democritus, you can put this down for those writing, the earliest recorded discussion of the basic structures of matter from ancient Greek philosophers are one, Leucippus. Let me write it on the board for you to see the spelling. In the note that you have, I didn't include that name. So but I'm adding this note to it, this name to it. The name is Leucippus, and Democritus argued that all matter was composed of small finite particles called atomos. Small finite particles called atomos. And the word atomos, the meaning is indivisible. 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 And they thought of atoms as moving particles. They thought of atoms as moving particles that differ in shape and size and could join together. So you're going to see that in the note. And you also need to note, please note, since the question is going to be OBJ, I can also look at some of these dates. So you're going to see that. But Aristotle does not agree with them. Aristotle and others concluded that matter consisted of various combinations of 4 elements. you're going to see that according to Democritus, he said there was a limit to how far you can divide a matter, that when you continue to cut a matter, you continue to cut it, it will get to a time that you will not be able to cut it again. It will be so small that you will not be able to cut it. And that is what they refer to as an atom. But Aristotle, so you have some information that you're going to see in the note. Aristotle disagreed with Democritus, and he said matter never end up with indivisible particles. That inside that small particle that you think you can still not divide, that you still have something that is smaller in it. That was the belief of Aristotle. And so he said matter consisted of various combinations of 4 elements. What are the 4 elements? Fire. He referred to fire as an element: earth, air, and water, and could be infinitely divided. Please don't distract me for now. Just keep your questions for now. They thought about atoms and elements as philosophical concepts. They only thought of them as philosophical concepts. They did not do any experiment. They did not bother to perform any experiment to test their ideas. And his view was believed to be true for 2,000 years. It was after 2,000 years that they now started, we now saw some scientists that decided to now take it further by carrying out experiments to confirm some of these things. And that is when John Dalton. So John Dalton revolutionized chemistry with his hypothesis. Revolutionized chemistry with his hypothesis. You can see 2,000 years later, revolutionized chemistry with his hypothesis that the behavior of matter could only be explained using atomic theory. His theory was first in 1807. Note all these dates, guys. 1807. His hypotheses are about microscopic features of matter and are still valid in modern atomic theory. And you know the 4 or 5. In some textbooks, you don't see that they put 4 there. In other textbooks, they put 5. One of them is that matter is composed of small indivisible particles called atoms. An element consists of only one type of atom. An element consists of only one type of atom. Atoms of one element differ in properties from atoms of other elements. A compound consists of atoms of 2 or more elements combined. You're going to see all this. And you can see. So Dalton used actual experiment. He started, and so he was able to use experiment. So he took that concept put forward by Democritus, Aristotle to another level by carrying out experiment on them. He introduced his idea in 1807. O3. And so these are what you know already, so I will not waste my time. I've already read out some of them. And from his work, it was possible that Dalton's theory proved the law of definite proportions. If you go back to your O-level chemistry, you're going to see law of definite proportion, the calculation and everything. He was also able to prove in one of his theories that you remember, atoms can neither be created nor destroyed, but it can only be rearranged. And that was used to explain law of conservation of mass. And so that explanation enables us to write chemical equations for our chemical reactions. So all these are what you're going to see in the notes that I'm going to send to you later. Okay, and some other information from Dalton's atomic law. What you're going to observe, that it was wrong about atoms of all elements being identical, because we now know that we have isotopes. And it was as a result of experiments done by some scientists that enables us to know that atoms of the same elements are not always identical. So you're going to see this in that note that I'm going to give you. The next set of information I'm going to push across to you will now be looking at evolution of atomic theory. Evolution of atomic theory. And it's going to outline milestones in the development of modern atomic theory. Remember, I started by saying, if I ask you to write electronic configuration for sodium, which is number 11, some of you will write it as 281. But rather than writing it as 281 these days, we use 1s2, 2s2, 2p6, and 3s1. So the question is, why is this one no longer correct? Why is this one no longer correct? Why is it that this one is preferred? You see that, remember, when you write your electronic structure, you say you have 2 electrons there. You have 8 in the second shell, and you have 1 in the third shell. So you are telling us that in the second shell, the 8 electrons in that second shell are of equal energy. But with this 1s2, 2s2, 2p6, we now know they are not of the same energy. So it is modern, the evolution of atomic theory, the modern atomic theory that gave that information. And it is only when you go through the information that you're going to understand. And that's the reason why you have to use the information that I'm going to pass across to you. Use textbooks to put everything together. So you're going to you will see that the development, milestones in the development of modern atomic theory. Outline milestones in the development of modern atomic theory. We summarize and interact the results of experiments. So in the next sets of information I'm going to push across to you, you're going to see information about what Thomson did, Millikan, Rutherford, Bohr model, before we now even get to Schrodinger equation that give us this method of writing electronic configuration. It's a long story, but we'll not be able to look at all the stories, or at least we're going to look at most of the information in the story. So you're going to see that the work by Sodid Where is the cleaner? Oh, sorry, guys. You cannot see my laptop, my tablet. It's a big tablet. And I always booger with my tablet. You can see my pen. I use pen. I can sit in my room and still teach you without seeing my tablet. So you can see the beauty of my tablet. So you're going to see that this guy called studied, won a Nobel Prize in 1921, and he did a lot of work on isotopes and radioactive elements. And so he was the one that was able to disprove that one part of information pushed forward by Dalton, that atoms of the same element are identical. So with the information about isotopes, we know atoms of the same elements are not identical. So you're going to see all this information. You can see 50 years after Dalton's proposed his atomic theory, a lot of other information developed, and that resulted in what we have today as modern atomic theory. So Michael Faraday. So some of the information I'm going to add to it is that 2 centuries after Dalton developed his ideas, 2 centuries. These are just the summary of what you're going to see in that note that I'm sending to you. 2 centuries after Dalton developed his ideas, significant progress were further made to understand the atomic theory using several experiments. So one of the experiments is the cathode ray experiment. Cathode ray. Or is it cathode tube now? Cathode ray tube experiment, yes. By J.J. Thomson. He's an English physicist. And he based his experiment. He was able to carry out experiments and observed the following: that the particles are attracted by positive charges and repelled by negative charges. They must be negatively charged. So he was able to prove the presence of electrons in an atom. So by the time you go through the notes, you're going to see all that. Cathode ray experiment was done in a tube. So what are the things that he discovered? Electrically charged particles. Atoms are made up of smaller negative. That inside an atom, you have a smaller negatively charged particles, and they call that electrons. In fact, the name of the person that gave that name electron is also known here. Might not be in that note that I'm sending to you. The term electron was coined in 1891 by Irish physicist called George Stoney. That's why. George Stoney, from electric ion. Okay? So you're going to see all that in the note. So Thomson's discovery was the result of doing experiment with cathode ray tubes. And from his experiment, you're going to see some of the information. That's the cathode ray tube. And what time is it? We have about 5 more minutes. 8 more minutes. Yes, sir. What can I do for you?
Yes, sir, I want to ask the date beside that J.J. Thomson. Is it the date he lived on Earth or how long it took for his experiment? I don't understand the date.
He did.
Yes,
Birth
sir.
to death.
Okay, thank you,
You're
sir.
going to see some information there. Don't worry, by the time you go through the note, I'm going to send the note to you guys. You can now. We don't have much time. Yes, who is this from systems engineering? Yes.
Sorry, sir. Sir, what was the year the name electron was coined?
I said, okay, the name electron was coined in 1891 by Irish
Okay.
physicist George Stoney.
Thank you, sir.
Thank you. Put down your hand. Yeah. So Thomson discovers small particles inside the atom. So which implies that atom is no longer the smallest indivisible particle that that thing made us to believe. And so it was also able to give us information about the charge on the atom. That is what? That the electron is what? Is negatively charged. So you're going to see all that information. Then we're also going to look, there are several models which I want you to look at. The plumb building model. You're going to see Bohr model of atom. You're going to see quantum model. Quantum model. That's the recent model that we use that gave us information that is now giving us 1s2, 2s2. There is Rutherford model. So we are going to, for instance, look at this pudding model. You should be able to differentiate between pudding model, Rutherford model, Bohr model, and quantum model. All these are the various stages of the development of atomic structure that we know today. So you're going to see the plumb pudding model. It's like when you have an ice cream, you now have small chocolate inside it. So the assumption then was that the structure of an atom is like that you have smaller structure inside that small atom. So he proposed that the atom was a sphere of positively charged material spread throughout the atom were the negatively charged electron, similar to plums in a pudding or chocolate chips in ice cream, because we know you like ice cream. That was some of the information put forward by J.J. Thomson. And you can see it's like that. Negative electrons inside positively charged spread inside the. Then in 1871, the man Rutherford, that was born in 1871 and lived up until 1937, won a Nobel Prize, also put forward his own model and disagree with his lecturer. So you can also disagree with us if you are able to sit down to study. You can also disagree with us if you have your right information. That model put forward by Thomson is not the correct representation of atom. And you cannot just say it without carrying out experiments. He did some experiments and he was able to put forward some information. So his experiment is a good foil experiment. And so you're going to see in the notes some of the information about that he was able to put forward. And in this structure diagram, if you look at it very well, you're going to see stream of electrons passing through the gold foil, and you see some of them being deflected, then some of them bounce back. So he was able to put some information together from the observations. And you can see, so what are some of the things that he observed? You'll see it in the note that I'm going to send to you. Most of the particles traveled straight through the gold foil. Then he observed that some of them were deflected and some even bounced back. And so he was able to also push some information across, which by the time you look at the note I'm going to send to you, it's a pity we have limited time, and that's the reason why I have to rush this way. But you also need to know that this is what we call lecturing. It's different from teaching that you used to have in the secondary school. Because of limited time, we'll not be able to wait for all of you, and we're also going to push the note across to you. So for today, I will pause here because it's time already, and I know you might have other courses. So on Friday, by the grace of God, 9 o'clock to 10 o'clock, I'll also be available to complete this story and move to how to write electronic configuration of atoms. And hopefully, if I'm able to complete that next week, a colleague of mine will come over to continue. Fawaz. Yes, sir. Fawaz, unmute yourself.
Sir, attendance, sir.
Yes. Go ahead.
Sir, attendance.
I can't hear you.
Attendance, sir.
You have attendance already now. That's why we ask you to put your information online. So you must always include your email, your matric number, name and surname, both those on for you on Zoom and those online. That's what is expected of you, and that will serve as attendance. Yes, Iku Dehibu Michael, unmute yourself.
What about the note that you said you are going to give us? You said we are going to get a note.
Send the note via this platform, via the WhatsApp platform that I created for the WhatsApp platform that I created is for the class reps alone. And I expect the class rep to communicate with you guys from time to time. I will always pass information to them. And there's also a platform created by the subdean of Faculty of Science. So most of the information I'm going to send, or we are going to send to you, will be through the platform that I've created and the one created by the subdean of Faculty of Science.
Okay, sir.
One more question before we go. I can see another hand up. Okay, I think I've answered the question. Thank you for your time, guys. See you on Friday by the grace of God. David, we have to go.